This short video introduces our tutorial at Supercomputing 2020, entitled C++ for Heterogeneous Programming, oneAPI, DPC++ and oneTBB. It will be delivered on Monday, November the 9th and Tuesday, November the 10th by James Reinders, Michael Voss, Pablo Reble and Rafael Asenjo. You are probably watching this video because you like C++ programming language, and you are well aware of the heterogeneous architecture ubiquity and of the importance of getting the most out of CPUs, GPUs, FPGAs, using a productive programming model like oneAPI. If this is the case, this is certainly a tutorial you should attend. If, however, this is not the case, let me motivate you for this tutorial by first explaining that heterogeneous architectures comprising CPU cores, GPUs, and FPGAs can be found in several supercomputers and data centers. But GPUs can also be found integrated in chips featured on desktops, laptops, tablets, and smartphones. As well as this, FPGAs are gaining momentum in HPC, automotive, security and industrial electronics, among many others. You do care about performance, right? But how to get the most out of CPUs, GPUs and FPGAs and live to tell the tale? This is where oneAPI comes to the rescue. oneAPI is a complete ecosystem of tools for developers that want to target CPUs, GPUs, FPGA and future accelerators. It comprises first of a unified standard-based programming model called Data Parallel C++, DPC++, and secondly of a large set of libraries, including one threading building blocks, or oneTBB for short. And finally, several advanced analysis, profiling and debugging tools like Intel Analyzer, Intel vTune, and Intel Flow Graph Analyzer. Although it is impossible to cover all aspects of oneAPI in a one-day tutorial, we will do our best to first introduce you to the general concept, but also to delve into the main aspects so that by the end of the tutorial you can develop your own heterogeneous applications. With all this, and in order to introduce you to this exciting topic and help you code efficient heterogeneous codes in a productive way, we have put together the following material. Part 1 first provides the general picture of oneAPI and follows with a hands-on session of DevCloud in which attendees will follow a Jupyter notebook with the first Hello World example and compilation instructions for CPU, GPU and FPGA. Next, the kernel execution model and the memory model is presented, paying particular attention to the buffer and unified shared memory abstractions. This part concludes with the mechanisms to select the device queue and in-depth coverage of the compilation flow. Part 2 begins with an introduction to oneTBB and the flow graph classes that will be used in combination with DPC++ to orchestrate and schedule computations among the different devices. Finally, oneAPI tools like Intel Advisor, vTune and Flow Graph Analyzer will come in handy to help optimize our heterogeneous applications. Attendees can take part in hands-on exercises using Jupyter notebooks tailored for each one of these blocks. By the end of the tutorial, attendees will know how to accelerate C++ programs using this unified data parallel C++ programming model, how to target multiple devices like CPUs, GPUs, FPGAs and combinations of them, how to leverage the library oneTBB to better map and schedule the different parts of the application into different devices, how to use the compiler and the tools to build, analyze and optimize the heterogeneous application, and how to exploit DevCloud to execute and assess the efficiency of the final executable. Regarding the presenters, James is co-author of the first book on data parallel C++, and also James, Michael and Rafael have recently published the latest book on TBB. We hope you will find this tutorial interesting and enriching, so please join us at Supercomputing 2020 this coming November the 9th.